Hey guys, okay, today we are going to talk about mole volume conversions. You already know, and what we've already covered is that 1 mole of any substance is equal to 6.02 times 10 to the 23rd particles of that substance. Again, if it's an element, it's atoms. If it's water, it would be molecules. If it's salt, it would be formula units. All things, but they're all particles. But we also know that 1 mole is equal to the molar mass. That's when you pick out your periodic table, look up the atomic mass. If you have multiple, you add it together. And that's in grams per mole, or grams. So all these things are equal. And it depends on the substance. This will change. This doesn't. It's equal actually to one more thing, and this is the last kind of rounded conversions that we're going to do. It's also 1 mole of any gas. This is only specific for gases, and we'll talk a little bit here why in a second, but it's only specific for gases. It's equal to 22.4 liters of that gas. So 22.4 liters. Let's visualize that. Okay, a 2-liter bottle, that's about 2 liters, 22.4. So it's a lot. 1 mole is equal to a lot. Why is it so much? Because we'll think about gases. There's a lot of space in between individual particles, and so it takes up a lot more space. And it says, so 22.4 liters of a gas is equal to 1 mole at STP. Back in my day, that would have been Stone Temple Pilots. But in this case, STP stands for Standard Temperature and Pressure. We have to define our temperature and our pressure for when we're dealing with gases. We have to make sure we know exactly which which pressure, and exactly which temperature. Why? Well, that's a slightly different explanation. Okay, let's talk about gas particles. Here I have some. Notice that they're far apart. They're very, very tiny. And they don't affect each other. If one gets close to one, it doesn't necessarily repel or it's not attracted to another. So they just kind of bounce off of each other. The other main thing you need to know is they are always moving. They are moving all over the place. Okay, so these guys are moving all over the place. But let's remove some of the energy that's in the system. Well, if you remove energy, what's going to occur? What's going to occur to the speed of the molecules? It's going to slow down. And so they are going to get closer together. And so what has happened to the volume of our system? It's gone down. Same thing if it reverses. If we increase the energy that's in it, as in we add energy to it, what's going to happen to these guys? They're going to start moving faster, and they're going to repel each other, not repel each other, but they're going to run into each other more, and they're going to expand, and they're going to go faster and faster and faster and faster. And so then there's going to be more space in between them, and so the volume increases. So whenever you remove energy, the volume decreases. Whenever you increase the energy, the volume increases. Same thing happens with pressure. If you want to close down the surroundings here, if we have a lid on this and we smash all of these down, they're going to get closer together. So that's going to lower. This is going to make the volume smaller. And if we open this up and expand this, then it's going to remove the pressure, and so the volume is going to increase. So gases are dependent on temperature and pressure. So that's why when we say that we are talking about gases at STP, and that's standard temperature and pressure, when we're talking about that, that's because we have to define what temperature and what pressure this is at. STP, standard temperature and pressure, is 0 degrees Celsius and 1 atmosphere. Okay, so you know 0 degrees Celsius is right at the freezing point of water. And 1 atmosphere, what's that? That's about the pressure, the air pressure at sea level. Okay, so these are our two confines. Our whole thing of 1 mole being equal to 22.4 liters only works in these conditions, and that's called STP. Okay, so now let's actually use that. You should have this sheet now, and this looks very similar to the conversion sheet we used before. We know that 6.02 times 10 to the 23rd particles is equal to 1 mole. The molar mass is also equal to 1 mole, but it's also equal to this 22.4 liters of a gas at STP. STP again, what is it? Standard temperature, which is 0 degrees Celsius, and pressure at 1 atmosphere. All right, so how can we use this when we're doing our conversions? Exact same way we have been talking. Make sure you know what's going in and what is it that you're trying to get. In this case, it says, how many moles of carbon dioxide do I have? If I have 2.5 liters of carbon dioxide at STP. At STP, what is that again? That means I know that we're defined at 0 degrees Celsius and 1 atmosphere. Those are our conditions. It doesn't work unless it's at those. Okay, so our mole ratio. What is it? What's our mole that we know? Okay, we're trying to get liters. Well, which one of these? It's not particles, not grams, liters. So we have 1 mole is equal to 22.4 liters. Okay, so again, just like we've used them before, just this time we're putting in liters. Okay, and so we know that for every 1 mole, it's 22.4 liters. We want to find out how many moles are in 2.5 liters. So how are we going to do this? Cross multiply, divide. So you're going to end up going with 2.5 divided by 22.4. And we've got 2 digits going in, so let's do 2 digits coming out. And this, of course, is moles. Okay. So again, similar to what we've been doing, just different number. I'm going to do one more with you. How many liters of carbon dioxide are I'm going to go, actually I'm going to run down to number 3 and do that one with you. We'll do that. A reaction produces 1,500 milliliters of oxygen at STP. How many moles is this? Wait, milliliters. Wait, what's milliliters again? Oh, that's right. There are 1,000 milliliters in a liter. So if there are 1,000 milliliters in 1 liter, then how many liters is this? Yeah, 1.55 liters. Okay. And so, again, what are we going to use? 1 mole is equal to 22.4 liters. But I want to know how many moles is 1.55 liters. Cross multiply, divide, 1.55 divided by 22.4. Let's see, we have 1, 2, 3 significant figures going in, so let's have 1, 2, 3 coming out. 0.069, and one more. 192. Okay. And again, what are we solving for? That was moles. Okay, this is where I'm going to end it because you guys kind of know how to set up these proportions. And just a new number, 22.4. Just pay attention. Again, what's coming in? What's coming out? What is it giving you? What is it that you need? Okay, go ahead and work through, I don't know, however many problems I assigned on that day.